Welcome back everybody to the third video in this multi-course explanation on trigonometry, where in this video we're going to be explaining the magic hexagon and the three respective trigonometric identities that it tells us, which are the Pythagorean identity, the quotient identity, and the reciprocal identity respectively, that we're going to be deriving by hand through the magic hexagon in this video today. To the left of the screen, you can see the magic hexagon all drawn out with the respective trigonometric functions on each end of the hexagon, with the number 1 in the center. You can see that we have drawn 6 triangles within the hexagon, which I'll be telling which 3 to use and which 3 to memorize, and how to derive each of the trigonometric identities. It is important to draw it as such in order for the information for us to derive to be correct. And with that, we can begin the lesson. We can start with sine. It's between the tangent function and the cosine function. Likewise, for the cosine function is between the sine function and the cotangent function. The cotangent function is between the cosine function and the cosecant function, which we apply for the remaining 2. And from there, we can derive our first one, which is the quotient identity. The quotient identity states the relationship between these 6 trigonometric functions with one another as in respect, as from the name itself, in quotient form, which is essentially what 2 trigonometric functions multiplied by each other will give us the third. Well, that will be sine of theta is equal to the product of its 2 surrounding trigonometric functions on the magic hexagon, which in this circumstance, or in all circumstances of the magic hexagon, are the cosine function and the tangent function, which I'm going to be drawing out right here as such. And here we have the first of the 6 in the quotient identity, which is sine of theta is equal to cosine of theta multiplied by tangent of theta. Then so on for the next one, which is cosine of theta, is likewise the product of its 2 surrounding trigonometric functions that are sine of theta and cotangent of theta, which applies for every other magic hexagon. Therefore, we can draw it out as such, with cosine of theta is equal to sine of theta. Sine of theta multiplied by cotangent of theta. Then we move on to cotangent. As the order I'm doing this is in clockwise order, which starting from sine ending at tangent, but really the direction you go doesn't really matter as long as you memorize the 6 respective identities. The cotangent of the function is equal to, as of sine and cosine, the 2 surrounding trigonometric functions respective to cotangent of theta. That is cosine of theta and cosecant of theta, which is cosine of theta multiplied by cosecant of theta. As always, if you do start to understand this concept, please do consider to pause the video and attempt to try them out and solve them on your own, and then return back to check your answers. Then we have the remaining 3, which are the cosecant of theta, the secant of theta, and the tangent of theta. Likewise, for how we did it for sine, cosine, cotangent, cosecant theta, secant of theta, and tangent theta is equal to the product of the 2 trigonometric functions that surround them, respectively. Starting with cosecant theta, we know the 2 trigonometric functions that surround it based on our magic hexagon to be secant of theta, and cotangent of theta. Therefore, cosecant of theta being secant of theta multiplied by the cotangent of theta. Then for secant theta, same thing. The 2 trigonometric functions that surround it are tangent and cosecant. Therefore, the product of the 2 will give us secant, tangent theta multiplied by cosecant theta. Tangent of theta, the two surrounding trigonometric functions are sine of theta and secant of theta, which gives us the product of the two trigonometric functions as such. And with that, we wrap up the first group of the quotient identities. Moving on to the reciprocal identity, which, based on its name, has to do with reciprocals of the trigonometric identities products. As we know from linear algebra, we know any constant of a or integer multiplied by its reciprocal, which we simply do 1 divided by the integer, will give us 1. 1 over a is the reciprocal of a, with the product of 2 giving 1. This rule applies for the same in trigonometry, which leads us to the reciprocal identity. If we scroll up to our magic hexagon, we can see this identity clear in our minds and with our eyes with the opposites of each of the trigonometric functions. Well, what trigonometric function is opposite the sine of theta? The sine of theta right here. Well, that is cosecant of theta right here. As we can see, a clear line right here, which the line symbolizes the reciprocals. Therefore, sine of theta with cosecant of theta being the reciprocal of sine will give us the product of 1. And likewise for cosine of theta and tangent of theta, we can see their reciprocals through the magic hexagon being the trigonometric function opposite to it, which for cosine is secant of theta, and for cotangent of theta being tangent of theta, with always vice versa as well. So we scroll down and complete this identity. So cosine of theta multiplied by secant of theta will give us 1. Tangent of theta multiplied by cotangent of theta will give us 1. And this sums up the reciprocal identity in trigonometry. And moving on to our final cluster of identities, which is the, it's the Pythagorean identity. Well, what is the Pythagorean identity? The Pythagorean identity has to do with the 3 triangles that I mentioned earlier for you to remember that allows us to derive this identity. We can see here these 3 triangles, which I'm going to be labeling or drawing out in green. You see this triangle, we see this triangle, and we see this triangle. We need these 3 triangles, not the other 3, so please do not get this confused. And from the 3 triangles, we do it by the left side squared plus the right side squared is equal to 1. So what do I mean by that? I mean by, let's say for sine of theta and cosine of theta, this triangle right here. Let's see this triangle here for an example. Sine of theta, the upper leftmost trigonometric function, added to its rightmost trigonometric function, which is cosine of theta, squared, of course sine squared as well, will give us 1. Which we'll write down here as the first in the 3 of the Pythagorean identity in trigonometry, which is equal to 1. Likewise for tangent of theta, well, let's not get ahead of ourselves, as let us look from the graph first. We see tangent of theta being the rightmost trigonometric function in this triangle right here. In this brown triangle. Therefore, staying true to our procedure as with sine and cosine in 1, we do the same thing for this triangle. The rightmost function squared being tangent theta squared added to 1 will give us secant squared theta. The second in our list of Pythagorean identities in trigonometry. So tangent theta squared plus 1 will give us secant squared theta. As always, if you do find this pattern to be helpful, please do consider pausing the video and trying to figure out the last one on your own. Well, in this one, as always, we find the rightmost term, which in this case is not a trigonometric function but 1. That doesn't matter, as in addition you could go vice versa. A plus b is equal to b plus a. So you could do 1 plus cotangent theta squared is equal to cosecant theta squared, or cotangent theta squared plus 1 is equal to cosecant theta squared. But for parallelism, let us remain true to the procedure that we did for the other two triangles. So for the rightmost term, upper rightmost term being 1 squared, which is still 1, added to cotangent theta squared, the left uppermost trigonometric function is equal to its bottommost trigonometric function squared, which is cosecant theta squared. Which wraps up our final set in our Pythagorean identity. This being cotangent squared theta is equal to cosecant squared theta. And here we have concluded all the information that this magic hexagon tells us. Hence the name magic hexagon. It is important to memorize all these terms, as in the next video we'll be diving into deeper concepts and into special angles of the 6 trigonometric functions, which we must remember through these 3 groups of identities that we have concluded today. I hope you learned something new, and I'll see you next time.